Welcome to my channel, Machine Learning. Today we discuss about two-cycle engine. A two-stroke, or two-cycle, engine is a type of internal combustion engine which completes a power cycle with two strokes, up and down movements, of the piston during only one crankshaft revolution. This is in contrast to a four-stroke engine, which requires four strokes of the piston to complete a power cycle during two crankshaft revolutions. In a two-stroke engine, the end of the combustion stroke and the beginning of the compression stroke happen simultaneously, with the intake and exhaust, or scavenging, functions occurring at the same time. Two-stroke engines often have a high power-to-weight ratio, power being available in a narrow range of rotational speeds called the power band. Compared to four-stroke engines, two-stroke engines have a greatly reduced number of moving parts, and so can be more compact and significantly lighter. Although the principles remain the same, the mechanical details of various two-stroke engines differ depending on the type. The design types vary according to the method of introducing the charge to the cylinder, the method of scavenging the cylinder, exchanging burnt exhaust for fresh mixture, and the method of exhausting the cylinder. Uniflow scavenging. The Uniflow two-stroke cycle top dead center, TDC. Bottom dead center, BDC. A. Intake, effective scavenging, 135° 225°, necessarily symmetric. About BDC, diesel injection is usually initiated at 4 degrees before TDC. B. Exhaust. C. Compression. D. Expansion, power. In a uniflow engine, the mixture, or charge air in the case of a diesel, enters at one end of the cylinder controlled by the piston and the exhaust exits at the other end controlled by an exhaust valve or piston. The scavenging gas flow is therefore in one direction only, hence the name uniflow. The valved arrangement is common in on-road, off-road, and stationary two-stroke engines, Detroit diesel, certain small marine two-stroke engines, Gray Marine, certain railroad two-stroke diesel locomotives, electromotive diesel, and large marine two-stroke main propulsion engines, Wärtsilä. Ported types are represented by the opposed piston design in which there are two pistons in each cylinder, working in opposite directions such as the Junkers Jamo 205 and Napier Deltic 9. The once popular split-single design falls into this class, being effectively a folded uniflow. With advanced angle exhaust timing, uniflow engines can be supercharged with a crankshaft-driven, piston 10 or roots, blower. The two-stroke engine employs both the crankcase and the cylinder to achieve all the elements of the Otto cycle in only two strokes of the piston. Intake. The fuel/air mixture is first drawn into the crankcase by the vacuum that is created during the upward stroke of the piston. The illustrated engine features a poppet intake valve. However, many engines use a rotary valve incorporated into the crankshaft. Crankcase compression. During the downward stroke, the poppet valve is forced closed by the increased crankcase pressure. The fuel mixture is then compressed in the crankcase during the remainder of the stroke. Transfer/exhaust. Toward the end of the stroke, the piston exposes the intake port, allowing the compressed fuel/air mixture in the crankcase to escape around the piston into the main cylinder. This expels the exhaust gases out the exhaust port, usually located on the opposite side of the cylinder. Unfortunately, some of the fresh fuel mixture is usually expelled as well. Compression. The piston then rises, driven by flywheel momentum, and compresses the fuel mixture. At the same time, another intake stroke is happening beneath the piston. Power. At the top of the stroke, the spark plug ignites the fuel mixture. The burning fuel expands, driving the piston downward, to complete the cycle. At the same time, another crankcase compression stroke is happening beneath the piston. Since the two-stroke engine fires on every revolution of the crankshaft, a two-stroke engine is usually more powerful than a four-stroke engine of equivalent size. This, coupled with their lighter, simpler construction, makes the two-stroke engine popular in chainsaws, line trimmers, outboard motors, snowmobiles, jet skis, light motorcycles, and model airplanes. Unfortunately, most two-stroke engines are inefficient and are terrible polluters due to the amount of unspent fuel that escapes through the exhaust port.